In the name of God, my name is Mehdi Kortnavasi, and this is the third movie of software architecture and design and the technique for architecture and design application. Let's start with the application overview. Let's start with the create an overview of what your application will look like when it complete. This overview serves to make your architecture more tangible, connecting it to the real-world constraints and decisions. An application overview consists of the following activities. The first, determine your application type. It is a mobile application, a rich client, a rich internet application, a service, a web application, or some combination of these types. Next, identify your deployment constraints. When you design your application architecture, you must take into account corporate policies and procedures together with the infrastructure on which you plan to deploy your application. If the target environment is fixed or inflexible, your application design must reflect restrictions that exist in the environment. Your application design must also take into account quality of service or QoS attributes such as security and reliability. Sometimes you must make design trade-off due to protocol restrictions and network topologies. The next step is identify important architecture design style. Each style defines a set of rules that specify the kind of components you can use to assemble a system, the kind of relationships used in their assembly, constraints on the way they are assembled, and assumptions about the meaning of how you put them together. An architecture style improves partitioning and promotes design reuse by providing solutions to frequently recurring problems. Common architectural styles are service-oriented architecture, or SOA, client-server, and layered and message bus and domain-driven design. Application will use often a combination of styles. The next is determine the relevant technologies. The choice of technologies will also be governed by organizational policies, infrastructure limitations, resource skills, and so on. The following section describes some of the common Microsoft technologies for each type of application. Let's see a short 3 minutes movie about Internet of Things to get some ideas of the contemporary applications we have to design.
The Internet of Things is changing much about the world we live in, from the way we drive to how we make purchases, and even how we get energy for our homes. Sophisticated sensors and chips are embedded in the physical things that surround us, each transmitting valuable data. Data that lets us better understand how these things work and work together. But how exactly do all these devices share such large quantities of data? And how do we put that information to work? Whether we're improving the production of a factory, giving city residents real-time updates on where to park, or monitoring our personal health, it's the common Internet of Things platform that brings this diverse information together and provides the common language for the devices and apps to communicate with each other. The process starts with the devices themselves, which securely communicate with an Internet of Things platform. This platform integrates the data from many devices and applies analytics to share the most valuable data with applications that address industry-specific needs. Let's start with a simple example, a car. After taking a long road trip, Rebecca notices that her check engine light has come on. She knows that she needs to have her car looked at by a mechanic, but is not sure whether it's something minor or something that needs immediate attention. As it turns out, the sensor that triggered Rebecca's check engine light monitors the pressure in her brake line. This sensor is one of many monitoring processes throughout the car, which are constantly communicating with each other. A component in the car called the diagnostic bus gathers the data from all these sensors, then passes it to a gateway in the car. The gateway integrates and sorts the data from the sensors. This way, only the most relevant diagnostic information will be transmitted to the manufacturer's platform. But before sending this organized data, the car's gateway and platform must first register with each other and confirm a secure communication. The platform is constantly gathering and storing thousands of bits of information from Rebecca's car and hundreds of thousands of cars like hers, building an historical record in a secure database. The manufacturer has added rules and logic to the platform. So when Rebecca's car sends a signal that her brake fluid has dropped below a recommended level, the platform triggers an alert in her car. The manufacturer also uses the platform to create and manage applications that solve specific issues. In this case, the manufacturer can deploy an application on the platform called the Asset Management System. This application oversees all of their customers' cars on the road, as well as all the parts in their warehouses. It uses the data from Rebecca's car to offer her a potential appointment time to service her car, directions to the nearest certified dealer, and a coupon for the service. What's more, the app will ensure that Rebecca's brakes are covered under her warranty, that the correct replacement part is ordered, and then sent to the dealership so it is ready when she arrives. But the manufacturer's analysis does not stop there. They have also deployed a continuous engineering application that tracks not only Rebecca's car, but hundreds of thousands of others, looking for ways to improve the design and manufacturing process of the car itself. If the same problem in her brake line crops up in a critical number of other cars, the manufacturer uses applications custom built for the automobile industry to pinpoint the exact problem. They can see if these cars were made at the same factory, used the same parts, or came off the assembly line on the same day. So what do all these pieces add up to? Streamlined inventory management for the dealer, a better, safer car from the manufacturer. And for Rebecca, it means she can be back on the road faster and get to where she's going safely. All thanks to the Internet of Things.
The next step is choosing the relevant technologies. When choosing the technologies you will use in your design, consider which will help you to support your chosen architectural style, your chosen application type, and the key quality attributes for your application. For example, for the Microsoft platform, the following list will help you understand which presentation, implementation, and communication technologies are most suited to each type of application. The first is mobile application. You can use presentation layer technologies such as the .NET Compact Framework, ASP.NET for mobile, and Silverlight for mobile to develop applications for mobile devices. The next is rich client application. You can use combination of Windows Presentation Foundation or WPF, Windows Forms, and XAML browser application or XBAP presentation layers technology to develop application with rich UI or user interface that are deployed and run on the client. The next one is a Rich Internet Client Application, or RIA. You can use the Microsoft Silverlight TM browser plugin or Silverlight combined with Ajax to deploy rich UI or user interface experience within a web browser. The next one is web applications. You can use ASP.NET, Web Forms, Ajax, Silverlight Controls, ASP.NET MVC, and ASP.NET Dynamic Data to create web application. The next technology is service applications. You can use Windows Communication Foundation, or WCF, and ASP.NET Web Service, or ASMX, to create services that expose functionally to external systems and service consumers. Okay, let's watch another short movie, 4 minutes, about how the Internet of Things will change the world, to get some ideas and for the future application we have to design.
It's the 100th episode of Forward Thinking. 99 shows ago, I launched this series with a discussion about the Internet of Things. In case you've forgotten, that's a term that describes a world filled with sensors and actuators and robots and computers that are all networked together and able to communicate with even larger networks. Now, in that first episode, I really focused on how the Internet of Things could affect our day-to-day lives in our own homes. Changing them from an elegant area of class to a swinging disco party with no effort whatsoever. But it turns out the Internet of Things is much, much bigger. Let's really think about the potential for a world filled with devices that can detect changing conditions and react so quickly it makes the blink of an eye look like an eternity. You're driving down the street on your way to work, and you're using your car's navigation system to give you turn-by-turn directions to cut down on commute time. Your car is communicating with sensors embedded in the environment, telling it the presence of other cars and bicyclists, even a pedestrian crossing the street 2 blocks ahead. Your car is also in constant communication with the city's traffic system. All of these sensors are working together to give you a smooth commute experience, cutting down on things that would frustrate you and funneling you through the best route, clearing your path of red lights and other delays. Now, doesn't that sound nice? I mean, this is a world that doesn't just react to what you need right now. It anticipates what you're going to need 5 minutes from now. It's like living a life of serendipity, an endless run of good luck. But it's not good luck. It's the Internet of Things, and it's working overtime on your behalf. But just to be clear, it's not all about you. The Internet of Things is going to enter industries like manufacturing and shipping, making them adaptable and responsive systems and increasing their efficiency. And with increased efficiency comes lower costs. It's an incredible vision of the future. To get there, scientists, engineers, and researchers are going to have to overcome some big challenges. We've talked about spectrum crunch on this show before. There are only so many wireless frequencies we can use, and you can actually hit capacity within any given area. Now, the good news is most of these devices in the Internet of Things are speaking in very small amounts of data. But when you have millions or potentially even billions of devices talking, it adds up pretty quickly. Then there's the cost. Now, the components in the Internet of Things are still under development, like sensors. They're pretty expensive, and other elements within the Internet of Things are even more so. So bringing costs down is one of the largest challenges we face today. Personally, I don't think any of these challenges are insurmountable. In fact, in 20 years' time, I think a lot of the things that frustrate us today will be a distant memory. No more traffic jams. No more leaving the grocery store and then realizing you forgot that one ingredient you needed to make dinner. And 20 years from then, I don't know. Do you think maybe good luck will just fade into obscurity? It won't mean anything anymore because that's what our lives will be? Sure hope so. Now, it's no secret that I'm an optimist, but I think this is a future that's worth striving toward. And guys,
Okay, thank you for watching this movie. And for the next movie, we continuing about the detail of quality attributes and testing the application performance. Thank you.